Okay, so this was the problem, jellyfish and the mix. So basically in this problem, what we want to calculate is pretty simple. Just a minute. Okay. So we wanted to calculate the mix of the array, uh, but there is a slight change in the pattern. What we are expected to do is we are given a variable called m. Let's say m equal to 0 initially. And then what we have to do is we have to remove, and there are some characters a1, a2, a3. There are some elements in the array, a5, a6, and you have to remove them in a strategic way such that this m. So once you remove that particular a of I from the array, you will have to add the mix of the remaining array to this m. So let's say example 0 1 2 3. If I add a 3, so you can see this mix of the array is currently 4, but if I remove 3, then we will basically have to add what, uh, 2, because the mix of the array is now 2. So that's what. So you have to remove all such ends, all the possible elements from the array. So remove everything uh, with the minimum cost. So that's what we are expected to do. So we have to remove every element from the array with the minimum cost. Yeah, so let's discuss the sample. So discussing the sample is not that quite like going to help us to drive to the solution. So first of all, you can see that if I sort the array, so observation are like this. So observations are like, if I sort the array, then the answer won't get affected. So we should go ahead and sort the array. So 1 2 3 and 4 and 5 as well. So we sorted the array, and thus we observe that the answer is not getting affected. Second part is, mm, that if I, let's say, pick a particular element. Okay, if we pick, an element, then uh, basically let me just write the sorting. If we pick an element, then its result will not affect. So if we pick an element, then we should pick the entire batch of the elements which are having the same value, because if we pick an element and if we leave that element behind, then that is not going to make any sense, because the mixers, let's say I have duplicates like this, 1 1 2 2. If I remove 1 1, if I remove only one, then the answer won't get affected, right? The mix will be still m only, whatever the mix is. Here m is 3, we know, but whatever the m is, it won't get affected. So I will try to remove the entire batch, right, so that the mix becomes exactly 1. Now the main issue with this problem is the direction of traversal is unknown to us. Like, how we should travel, should we travel from the back to front or front to back? That's not very much clear intuitively. So let's go with this first example, because these examples are not going to help that much, so we have to go with this flow only. So now let's try to think, if I go from this direction, uh, then what is my expectation? Like, if I remove all these three zeros, my answer will be my if I remove all these three zeros, first of all, my mix here is 6. Okay, so I'll have to pay 2 mix and then 1 0, right? Because after that the answer would be 0. So I will have to pay 6 plus 6 plus 0 plus 0 plus 0 plus 0 for everyone. So once my mix is becoming 0, then I don't care about the number of elements. So basically you have to make mix equal to 0 at any cost. Okay, and it will definitely become 0. But here you can like imagine ki I will have to pay a mix of this 6 if I wanted to remove these two zeros. But what if I removed 3? Then my mix will become 3, right? And that is much more easy for me, because now for removing 3 I will pay 6 mix, and then thereafter uh, sorry, for removing 3, if I remove 3, then I'll have to pay exactly 3 cost. And after this, if I go ahead and remove these 3 zeros, I'll have to pay only 3 plus 3, and that is much lesser than what this is offering us. So it turns out that if I start from the front to back, we are not able to understand which mix we should have removed, so that this current mix cost is less, right? So what we are targeting here is uh, we should move from front to back, not from front to back, from back to front. Okay. Now what we are going to do is we are going to remove the elements, the batch of elements which are same. Let's say there is one more 3 here. We are going to remove all these two threes, and then what we are going to do is we are going to update our mix. So the recursion is like this. So it's kind of pretty simple recursion. So we have two parameters in the recursion: int solution, okay, int indx comma m. So this m represents the current mix. Okay. So if this base condition is that if index is less than 0, that means we have reached this position, then we can straight away return what? 0. But there is one condition, that my mix should be 0 at the end, right? So if mix is 0, then only return this, otherwise return some big number. Okay. Now this is not the case. Then what we have to do is we have to calculate how many group, what is the size of this group. So I'll calculate this with this int count is equal to 0. For I equal to 0, we can go with I index, I is greater than equal to 0, I minus minus, and we just calculate what is the frequency of these elements. Okay. So we can do this like before entering into this loop itself, but still I am doing it here. So we just do count plus plus, and else we do break. Now what we have to do is we have to pay the cost of creating this particular element as a mix. So the cost will be, as I've told you, that count minus 1 times the previous mix which was there plus the current element, right? So that's the cost. So after we pay this much cost, we just now have to check. So we make this answer variable equal to infinity again, and answer will be equal to minimum of whatever the answer we got, comma, this cost we have to pay plus we just move back, index minus count, comma, mix will be updated to not mix, it will be array of index. Else we always have an option of not making this as a mix, and we just continue our journey with solve of index. And if we ignore a particular element, then we'll ignore that entirely. We are not going to choose any one of them. We are just ignoring that in. We are going to ignore everything from it. So that's it. So this was the question. I hope you understood this part. Thank you.